Hello, this is the second matrix video for OCR Pure Core AS Further Maths, and it covers multiplying matrices. Here we have two square 2x2 matrices. To multiply them, we multiply cell elements from each row of the first matrix by cell elements of the second matrix. So, the first row, we multiply 1 by 2, in other words, this element here by this element here, and then we also add the 4 times 2. If you put brackets around them, that makes it a little clearer. Moving along then, we look at the first row times the second column, in other words 1 by 1, and then we add 4 by 3. The second row times the first column would give us minus 2 times 2 plus 1 by 2, and then minus 2 times 1 plus 1 by 3. When we work out those products and sum them, we will find we get 10, 13, minus 2 and 1. It may not be a great surprise to you to know that if you multiply two 2x2 matrices, you end up with a product matrix of the same size 2x2. If you want to have a go at doing that for yourself, please pause the video now. Whereas for addition and subtraction, we did have to have matrices of the same size, and in this example, we did have matrices of the same size, we can multiply matrices which are not of the same size. In this example, we have two non-square matrices of different sizes. You may want to pause here to think through any restrictions on different sizes and compatibilities. Let's try and see if we can actually multiply these together. Well, we know that we have to multiply that cell by that cell, so 2 by 1, and then working our way along the first row and down the first column, we would have a 3 by 2, and then we would also add a 1 times minus 4. See, I'm going to run out of space here, but never mind. If I then look at the first row and the second column, and I'll start over here, we would have a 2 times minus 2, plus a 3 times 0, plus a 1 times 5. Okay, so far I would have had a 4 and a 1. If I look at the next two entries, I would have minus 1 times 1, plus 2 times 2, plus minus 4 times minus 4, giving me 19. And the second row times the second column, I would have minus 1 times minus 2, plus 2 times 0, plus minus 4 times 5. When I sort all that out, I get minus 18. So in this particular case, whilst we started off with a 2 by 3 matrix and a 3 by 2 matrix, the product is of size 2 by 2. So in the former case, it was possible to multiply the matrices. However, in this case down here, let's see what happens. Well, we can do 1 times 2, and then we can add 3 times 2, but then we have nothing to multiply before by. So that's not going to work. Those matrices are not conformable as far as multiplication goes. So the number of columns in the first matrix, if it's equal to the number of rows in the second matrix, then we can say the matrices are conformable with respect to multiplication. However, in that second example, that was not the case. In general then, If you have a matrix of size p times q and you want to multiply it by a matrix of 2 times r, as long as those two numbers are the same, you can multiply them and you will end up with a matrix of size p times r. So if the question asks you whether or not two matrices can be multiplied together, that's the aspect you need to look at. Sometimes it's possible to multiply a times b, but not the other way round, b times a. Something else that may catch you out is when they ask you to square a matrix. You may think that squaring a matrix would be done by squaring each of the elements, in other words 36, 1, 16 and 4, but that is not the case. Let's look and see what actually happens. When you multiply a by a to give yourself the a squared, you must carry out matrix multiplication as normal. So in other words, yes, you have 6 by 6, but you must also add 1 times 4. Moving along then, first row times second column, you would have 6 times 1 plus 1 times 2, 4 times 6 plus 2 times 4, and 4 times 1 plus 2 times 2. That would then give you 40, 8, 32 and 8. If we look at a times b, we can see that it doesn't matter if we don't know the value of all the cell entries. Indeed, in this particular question, there may be a further part where that is part of the question. So, in this case, we've got 6 minus 6 there. We've got 4k plus 2c, and we've got 4 minus 12, and that would give us a result of 6k plus c, 0, 4k plus 2c and minus 8. That AB equals 8008. Let's just remind ourselves that that was 6k plus c, 0, 4k plus 2c, minus 8. Then, just as we had probably at GCSE, you can form two simultaneous equations in two unknowns and solve them to find out the values of k and c. So I'm just going to double that top one, and then by eliminating 2c I end up with 8k equals 16, otherwise k equals 2, and then by substituting back into that first equation I can, by a little bit more work, get to c equals minus 4. So there we have looked at the basics of matrix multiplication, and in the next session, 1.3, we will look at further properties of matrix multiplication.